Hello friends, welcome to engineering tutorial. So in this video we are going to discuss different values, different parameters with which we use to represent alternating current or which convey important information related to alternating current. So we have so far discussed the basic concepts related to alternating voltage and current, the basic definition of alternating AC voltage or current, which is it is a parameter which changes both in terms of magnitude and direction. So the application of AC voltage to a circuit results in alternating current, which is expressed in terms of this. This is the alternating voltage or EMF, which is expressed in terms of sinusoidal expression, mathematical expression, and that results in alternating current, which is expressed as this. So far we have discussed the basic concepts and then the important terminologies associated with AC, that is amplitude, frequency, time period, cycle, half cycles, all that. Now there are different values which give us important information related to an alternating quantity. See, whenever we are analyzing a DC signal, okay, whenever we are analyzing a DC parameter, it is simple. Why? Because the parameter is fixed in terms of magnitude and direction. So simply by giving us the value of the voltage or current magnitude, it conveys almost all the important details related to it. But for AC, we need several things. We need to know the amplitude, we need to know the frequency, we need to know the phase angle, then there are other things, time period, cycle, all that, which are interrelated of course. Along with that, we need some extra information also, okay, which convey important information related to that signal. So they are the peak value of alternating current and voltage, the root mean square value, the mean or average value, and the peak to peak value. So first we'll discuss the peak value. It is very simple. The peak value is very simple. It is simply the maximum value attained by an alternating signal, an alternating quantity, voltage or current. So it is the, in other words, it is the amplitude of the voltage or current signal. So we know that an alternating parameter, it has both half cycles, positive and negative, and the positive peak is equal to the negative peak in terms of magnitude. It is opposite in sign, but magnitude wise it is the same. So simply this is the positive peak, this is the negative peak. Okay, this is the positive peak, the maximum value attained during the positive half cycle. This is the negative peak, the maximum value attained during the negative half cycle. So the peak value is simply the modulus of that, which is the magnitude, the maximum value attained by the signal. So it is, in other words, we can also say this is the amplitude. Amplitude is the same as peak value. Okay, this. So this is one value. Next we have, similarly for current also, Imax is the peak value or the amplitude. Okay, that. So this is for voltage, this is for current. Next we have, so here I have expressed that Vmax or Imax, Vp or Ip. It can also be represented as Vmax Imax or Vp Ip. Then we have peak to peak value. Now this distance from the positive peak to the negative peak, this total distance, this is called as peak to peak value. The peak to peak value, the gap between the positive peak and the negative peak. So as we know that both the positive and negative peak, they are equal in terms of magnitude. So the peak to peak value, which is the difference between the highest or the positive peak and the lowest or the negative peak in a waveform, it is expressed as this. The voltage peak to peak value, it is the positive peak, this, minus the negative peak. So minus minus it becomes plus, so it becomes 2 times the peak value. 2 times the peak value. Same for current, 2 times the peak value. Okay, this in terms of magnitude. So this side gets added, so it becomes 2 times or twice the peak value, both for voltage and current. Okay, the difference between the positive peak and the negative peak, the highest and the lowest values of the waveform. Next we have the mean or average value. Now this is very important to understand. We have this alternating signal waveform. This is the voltage signal. So it has a positive half cycle and a negative half cycle. So it has different instantaneous values. Let's take another simple diagram. Voltage signal. Okay. So let's say the current signal. Also voltage, current. What I'm trying to say is that starting from here till it completes one complete cycle, it has different instantaneous values. Okay, at this time instant, let's say it is V1, then at this time instant, let's say it has V2, then at this time instant T3, let's say it has V3. Similarly, at this time instant T4, let's say it has instantaneous V4. So as many instantaneous values, let's say we take n number of instantaneous values. So the number of instantaneous values it has, the average of all that for the total time period, for the total time period of the signal, as many instantaneous values it has, the average of all that gives us the mean or average value. Now, for a symmetrical alternating signal waveform where the positive half cycle is exactly the opposite of the negative half cycle in terms of magnitude and direction, where the positive peak and the negative peak, they are same in magnitude. The problem is that the positive and negative values, they cancel out each other. Okay, the positive and the negative values, they cancel out each other. That's why the average signal becomes 0. So for such a computation of such a value, what we do, the positive half cycle, what we do, we take the total area under the curve, the total area under the waveform, and divided by the base length, the time period length. We do the total area under the curve, the total area under waveform, divided by the base length of the waveform. This gives us the mean or average value. But the problem is the positive and negative half cycles, they are equal in magnitude and opposite in direction. So the positive half cycle, it is assigned a positive area, and the negative half cycle, it is assigned a negative area. Both the positive and negative areas, they cancel out each other, and the average value, it becomes 0. But the average value is not 0. So for the analysis of symmetrical AC waveforms like this, we only take half cycle. We only take one half cycle for symmetrical waveform. This is a symmetrical waveform. This positive half cycle is the mirror image of the negative half cycle along the x-axis, but equal in magnitude, opposite in direction. That's why they cancel out each other. But for unsymmetrical waves, it is not that case. For that, we can take the total area. But for symmetrical waveforms, we only take one half cycle. Okay, so the average value is the total area under the curve during the time period t divided by the time period. For symmetrical waves, we only take the half cycle, we only consider one half cycle. So for symmetrical wave, it is the area of one half cycle divided by the base length of one half cycle. For unsymmetrical wave, this is the area of the full cycle divided by the base length of full cycle. Okay, for unsymmetrical waves. So far we have not encountered any unsymmetrical waves, but that is the case. There is also another very important and easy method to determine the mean value or average value. This is called as the mid-ordinate method. Okay, it is called as the mid-ordinate method. So the mid-ordinate method is actually a very simple method. So in that method, what we do, so we take only one half cycle, preferably the positive half cycle. Okay, we take the positive half cycle of the signal, this. Okay, and what we do, we divide the total time duration of the positive half cycle into n equal parts. Okay, n equal parts of equal width. Okay, the width of each part should be the same on the time axis. Okay, this gap, this width, it is the same for all. Now then what we do, we take the middle portion of each part, the middle portion of each part. So here the more the value of, the higher the value of n, the more accurate the result. So this middle portion of each part, we calculate the value of that. x1, x2, x3, x4, and for the nth part it is, let's say, xn. So x1, x2, x3, x4, as many parts there are, then as many values are there. So this middle value of each part, these are called as the mid-ordinate values. The process is demonstrated here. So we have taken the positive half cycle. So what we do, we split the entire positive half cycle into n parts. These black lines, vertical lines, they represent the demarcation of the positive half cycle into n parts. And then these red dotted lines, they are the middle portion of each part. Okay, and these are the mid-ordinate values. Since we have taken a current waveform, so these are I1, I2, I3, they are the mid-ordinate values of the current. Okay, I1, I2, I3 up to In, they are the mid-ordinate values of the current waveform. Okay. Similarly, if you would have taken voltage, then it would have been V1, V2, V3, Vn. Okay, so then what we do, we simply take the sum in the numerator of the mid-ordinate values, nth values, n number of values, divided by the number of demarcations, the number of individual parts into which we have divided the waveform. So this is called as the mean value or average value. If it is current, then it is I1 plus I2 plus I3 plus the nth part divided by n, and if it is voltage, then it is V average or V mean, which is equal to V1 plus V2 plus V3 plus Vn by n. So always remember the mid-ordinate method. We take the positive half cycle, only one half cycle is considered, preferably the positive half cycle. We split the entire half cycle area into n parts. Okay, with the width of each part on the time axis being equal. Then we take the middle portion of each part signified by these red dotted lines. Then we plot their values. What is the respective value? Okay, this I1, I2, I3, then IN, similarly like that. Okay, then we take those values which are called as mid-ordinate values, and we simply take the sum in the numerator divided by the number of mid-ordinates, or the number of parts. That is called as the mean value or average value. Okay, this is called as the mid-ordinate method to determine mean or average value. Then we have another important parameter which will derive from the mid-ordinate method, that is the root mean square value. So here we will proceed in the same manner. Take the positive half cycle, divide it into n parts of equal width on the time axis, then determine the middle portion of each part, which is called as the mid-ordinate. For voltage V1, V2, V3, Vn, for current I1, I2, I3, In, like that. But here the mathematical expression is slightly different. For current, IRMS is equal to I1 square plus I2 square plus I3 square plus the nth value, mid-ordinate value square, divided by n, then square root. For voltage, same thing, V1 square, V2 square, V3 square plus Vn square divided by n square root. So here, as the name suggests, the root signifies this square root. The mean, it signifies the average of all the squares, okay, this by n, the mean, and the square, it signifies the square of each mid-ordinate value, this, the square of each mid-ordinate value, okay, square. So root mean square, square root mean square, this signifies the root mean square value. Okay, this is for current. For voltage, similarly, V1 square plus V2 square plus V3 square plus Vn square by n root over. This is the root mean square value. It is taken in the same way, the mid-ordinate value, as we did it for the mean or average value, but the calculation is different. For mean or average value, simply we take the average of all the mid-ordinate values. Here we take the average of the squares, then we take the square root. Okay, the mean of the squares and then the square root. That is the difference. This is the root mean square value. This is the mean or average value. Then we have also mean or average value. There is some more discussion related to it. We'll discuss it in upcoming videos, where for each individual alternating voltage and current, will determine their mean and RMS values. There is other mathematical expression for that also. This is the simple calculation form. Okay, so here we have discussed the different values, the important values, the peak value, peak to peak value, mean or average value, and root mean square value. Okay.